Welcome to 45th lecture in the course of Industrial Engineering and Operations Research. We are discussing operations research, and in that topic is transportation models. In the last few lectures, we discussed various methods to generate initial basic feasible solution. So, simplest was northwest corner method and the toughest was Vogel approximation method. Now, today I am going to move further ahead and conclude this topic by telling that how to optimize the results. Okay. So, for that purpose, again let us take the same problem. Some special items are produced at factories at Patna, Guwahati, Mumbai and Hyderabad. Okay. This is given here in this column. Distributors are located at Lucknow, Delhi, Jaipur, Chennai, Kolkata. And supply and demand of items are indicated in the table, who supplies what. Note that factories have capacity to produce 18,000 items. Just see that supply from Patna is 3,000, from Guwahati 6,000. So, 3, 6, 9, 4, 13, 5, 18. But only 15,000 items are in demand. Lucknow demands 2,000, Delhi 7,000, so 2, 7, 9 plus 4, 13 plus 14, 15. So, demand is only 15,000. Therefore, we have to make some dummy destination. Transportation cost of each item is proportional to distance it travels. That is why I just have written the distance between these cities. And in kilometer, same can be considered as the cost of transportation per unit. Okay. Now, what we did that we made the dummy one, and by north west corner method we got this type of allocation 2,000, 1,000, 6,000, 4,000, but we see that we have got only 7 cells fill 1, 2, 3, 4, 5, 6, 7, while we need basically 9. So, minimum total transportation cost by northwest corner method came out to be this much, 2 crore 4 lakh 70,000. Okay. And number of allocated cells is equal to 7, which is 2 less than m plus n minus 1, that means 4 suppliers and 6 destinations including dummy one, 4 plus 6 minus 1, hence 9. So, hence this solution is degenerate. So, to resolve degeneracy, we make use of an artificial quantity. I am indicating it by A, but A is basically 0. We have to make sure that there are n allocated cells, hence we allocate 2 artificial quantities A equal to 0. So, now what we do that here, we have already filled up 2,000, then after that 6,000, then suddenly I had come this one. If step by step I move, I should have written A here, maybe I can write A here, and then 4,000, then 4,000 to I move vertically, and in vertically I have put A, because I could have written in 1330 also I could have written A, that would also have been this thing, but I have just have written in 1470. Okay. So, either I can go to adjacent horizontal cell or I can go to adjacent vertical cell. Since I spotted that in Guwahati to Delhi cell 6,000 was allocated, but nothing was allocated either on the right side or in the just below cell. So, that is why I just decided to put something in just below cell, and same thing I did in the Jaipur Mumbai cell also. And now we have got these 9 occupied cells. So, what we do that here, we make use of one method which is basically, if I want to give derivation in detail, but that I will not do that. It is based on the dual solution, and I had told that the primal problem of the transportation can be written in the normal standard LP form, and when we make the dual, then dual variables were u and v. Okay, we indicate by u I and v j. So, I can say that u I and v j, they are basically multiplier, and u I is associated with each rows, something that means with each factories, and v j is associated with the destinations. Now, how? So, naturally there are basically 4 factories: Patna, Guwahati, Mumbai, Hyderabad. So, basically 4 UIs, U1, U2, U3, U4, and we will have 6 VIs. That means V1 is Lucknow, V2 means goes to Delhi, like that. So, 4 plus 6, that means total 10 variables, but out of that basically 1 is dependent. So, the independent one basically 9. Okay. So, basically because 9 equations, constraint equations were there. Okay. One is of course because of the balanced problem, one is equation is redundant. So, basically we need 9 values, and for that purpose we need 9 equations. How do we get 9 equations? We put that condition that CIG, cost component, is broken into 2 parts: UI plus VJ, cost of transportation from I to j, and we can say Cij is equal to Ui plus Vj for the field cell. So, since we have now 9 field cells, including the cells in which I have given 0 allocation and designated by A, so including that we have 9 cells. So, naturally we can write 9 equations, and I can get U1, V1 easily, and there will not be any difficulty. So, that is what we have to do as a first step. First do that, then remaining thing I will tell you next, that what to get that. So, thing is, this method is called modified distribution method or MODI method. Okay. So, find Ui and Vj for all occupied cell, where Ui plus Vj is equal to Cij, and I have written these basic variables. I am designating x11, and finally x47 is also filled, that means 4th row, 7th column, and 46, and this is equal to, no, this must be 4th row and 6th column. Okay, that means this is equal to this one, 1, 2, 3, 4, 5, 6. Okay, there are only 6 columns. So, 4, 5, x11. Okay, and this is x12, x22. So, x11 was 610, u1 plus v1 is equal to 610. Then similarly x45, x4 means Hyderabad, and 45 means Delhi, 1, 2, 3, 4, 5. That means 4, 5 means this is 630, 1, 2, 3, 4. It should have been 4 only. That is okay. Let me just do it here. Okay, that minor, this one 4, 3, and this is I think 4, 4, and this is 4, 5, and this is 4, 6. Anyway, doesn't matter. It is only that some designation problem, but means I am writing equations for all field cell. You see, first field cell was 6 in 610 one, that in which the cost is 610, that is 1 cell, first row, first column. So, u1 v1 is equal to 610. And similarly, if I go to this one, where I have allocated 3000 in the dummy one, that is basically 4th row and 6th column. So, this is u4, but the cost is 0. So, u4 plus v6 is equal to 0, like that we have done. So, naturally that we can solve these one by one, and in the beginning that we can take that u1 is equal to 0 arbitrarily, so that we can get proper solution. So, u1 can be put arbitrarily equal to 0, you can put anything else also, but convenient to put 0, and then for remaining you can keep solving. Once you assume u1 is equal to 0, you can say v1 is equal to 610, u1 is known, again v2 is equal to 1060, like that you can get u1, v1, etc. So, this systematic way I have written just to explain, but in the exam if the time is less, I may do that very fast, and I may say that simply like this, u1 is equal to 0, I will just put this one, and then I will keep doing this one. So here 610. So therefore we say V1 is equal to 610. Okay, I just concentrate on one cell at a time, and this is U1 is equal to 0. First row is already 0. So V2. So this is V2. Now V2 is equal to 1060, because so that U1 plus V2 becomes 1060. Okay, and then after that I can come to U2. So how much is U2? Because this is 1060 and this is 1910. So therefore 1910 minus 1060, that becomes 1910 minus 1060. So this is 0, 6, 5, 11, and this is basically 8. So basically it becomes 850. Okay, so 850. So this is 850. Let me see that I have written 850. Yes, 850 there. And then I can go to this one. U2 this cell is okay, and then I can come to this one 1420 thing. Okay, so this is 1060, but I have to write U3. So U3 plus V2 will give me 1420. Okay, third row and second column. So this will be simply this one 1420 minus 1060. So this will be 0, 6, 6, 12, and this is 3. So basically it will be 360. So U3 is equal to 360, like that. And once I have known U3, then now I can go, because U3 this thing I know, so I can easily find out V3 here, because this cell is filled. So V3, this is 360, but this is 1150. So VT must be equal to 1150, and then I could have said 360 minus, so this is 90, and then I had to borrow this one, so 790. Okay, because this is 790 means 850, and this one. So V3 is equal to 790. Okay, let me see that we have been writing like that. So like that I can complete. Okay, I can keep completing. I need not write here itself. I can do that type of thing, and then I can do that way. Okay, so fine. So that so now what we do after doing this, find DIG. It is something called opportunity cost for all unoccupied cells. So opportunity cost for all unoccupied cells is found Ij. Dij is equal to Cij minus Uij plus Vj. We have to do. For occupied cells it is equal to 0. So that means unoccupied cell, suppose 1, 3, 1, 4, 1, 5, 1, 6, in that you have to do that. So we have to do that. We find that Cij minus Ui plus Vj. So we got that in many places we are getting positive values. That means cost is actually more than something, actual cost is more than the imputed cost. So we don't have to do anything to that, but in the negative one it indicates that it is not yet optimized. So we are getting in one cell, that means second row and fifth column, we are getting very large negative number, that is minus 652 highest. So therefore that one we will take, we will try to allocate maximum amount to this one and transferring the amount from other cells. So you identify the minimum negative, that means least value in negative side, and then we do that. So how do I allocate that? Suppose we have second row and fifth column. So second row is Mumbai row and fifth column means this one. So 2/5 this one. Okay. So this is equal to x25 minimum negative, and this is equal to this one 652, and this will be, so there was nothing. Okay. So it is something like that. Here you have to allocate that maximum amount to this quantity. Okay. So here we have this one. Okay. So we will be going like this, that here we will try to choose the minimum negative value. So here since comes out to be D25. Okay. So we draw a closed path from the corresponding cell. That means this cell was Guwahati 25. Okay, that means we have to see the second row. So second row is Guwahati and fifth column is Kolkata. So 25. That means this cell was giving me opportunity cost minus 630. So we want to give maximum amount to this. But how much maximum amount? Let us say that I want to give theta, and then from here I want to make a circuit type of thing, closed path. How I should make a closed path? That from this you move either horizontally or vertically, but you can take a turning only at the field cell, and then you can complete this circuit. Say for example, from here no use in going in the horizontal direction because there is hardly anything, only one dummy column is there. Come down and you see the field cell was this 1501 was the field cell. So you came here and you said that already 1000 was allocated to it. So you say that 1000 minus theta, something value theta, and here you can take a turning now. So that means you can take horizontally towards left hand side. You came up to this where the cell is filled and you said here 0 was allocated. So you said 0 plus theta. I am telling right now theta only. Then you go to vertically up and you get here say 4000 was allocated to this. So you say 4000 minus theta. You keep doing plus minus alternating one. That means in the same line, either horizontal or vertical, if one is plus, other will be minus. So here you go to that again horizontally towards left and up to field cell. So you said that there some 0 was allocated, but you said 0 plus theta, and then you go here, you got take them this one 6000 and you say minus theta, and then you go like this horizontally again and you came to the same spot, there is theta. So the closed circuit has been made. Like that you have to identify the closed path. So here closed path is Guwahati, Kolkata, Hyderabad, Kolkata, Hyderabad, Jaipur, Mumbai, Delhi, Guwahati, Kolkata. So you just see that here I have given theta to, if I have given theta to Guwahati, Kolkata cell, then in the vertically below another cell minus theta, then horizontally this side plus theta, then this is minus theta, then this is theta plus theta, then this is minus theta, again this theta. So that type of thing. Now what should I take the value of theta? So I should choose the value of theta in such a manner so that nothing becomes negative, no allocation becomes negative. So I am seeing that what is the method? Concentrate in those cells in which it is written minus theta. Among them I have say something like this, least is 1000 minus theta. So least allocation was 1000. So I cannot take theta more than 1000. I can take theta 1000 so that this becomes 0. If I take theta is equal to 2000, this will become negative. That is why I have taken theta is equal to 1000, and instead of this one theta, now you can erase the theta and you just put 1000. So that's what earlier in this slide it was showing. So this is 1000 and this is 1000 minus. So that way the things will be getting modified. Okay. So we get modified like that, and then you see that after that we will get allocated one, this one. So after allocation, now Guwahati, Kolkata has 1000 and some cells has become 0, and still there are, you have to ensure at this stage that always there should be 9 cell filled. By the way, something becomes 0, some another cell also become, then again you have to give at least one cell some dummy number. Okay. So here let me see 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 cells are filled, we need only 9. Now total transportation cost here you can calculate, just multiply 610 into 2000, 1060 into 1000, 1910 into 5000, 1001 into 1000, 1420 into 1000. So total comes out to be 1,98,18,000. This much it has come. Okay, so this okay, so this is how that total transportation cost got reduced. But again you have to find out U and V in the same manner. So if I do that, this one, this may be even faster. I can say like this, that here it is U1 is equal to 0, it may take some time, and V1 is equal to 610 because this is filled up, and I can say V2 is equal to also 1060, like that I can do that type of thing. But here we have indicated in a systematic way that we have for all occupied cells we have written that equation U1 plus V1 is equal to cost. So, U1 plus V1 is equal to 610, and this is like that, and these are the values I have done. Okay, I can do much faster instead of writing like that. From here I can do, say suppose V2 is equal to 1060. So, in the second column you come here and Guwahati. Now, Guwahati Delhi column 1910. So, naturally that 1060 and 1910. Okay. So, you can say 1910 and this is 1060. So, 0, 6, 5 and this is 8. So, 850. So you can say U2 is equal to 850. Here itself you can write. And similarly, this is also filled. So, here it is 1060 and this is 1420. So, this will be 1420 minus 1060. So, this is 360. So, you can say U3 is equal to 360. Like that you can just see that for any cell thing you need U means U of that row and V of any column. So, you can see that which one is your label and the other one you can find out by the formula. This will take much less time, but I am not doing complete just to save some time. Okay. It is already given, these things are given. And then once we have done like this, then we can for unoccupied cells again we can find out the opportunity cost, that is Dij is equal to Cij minus Ui plus Vj. And then I am getting that some in some cells this value is negative, particularly in x21 second row and first column. This is the least negative, minimum negative, that is minus 440. So, we should try to give maximum there, second row and first column. So, that means here second x2, what is that, x21. Okay. So, second row, this is the thing, okay, minimum negative. So, that means here, okay, maybe that here there was basically nothing, okay, 10, it was 1020, it was unoccupied. So, here I indicate that this is plus, and let us say I am giving theta, then I can move vertically up because this is filled cell. Here I can take turning also, and this I could have said 2000 minus theta. Then I come to this side, the side, and then I give that plus theta, and then I come down here and I could give theta. So, I could see that in the negative cells, least allocation was to Lucknow Patna cell. So, there 2000 minus theta. So, that means maximum I can give theta is equal to 2000. So, that means I can allocate 2000 here in Guwahati, Lucknow, and in Patna it will become, value will become 0, then Delhi it will be added 2000, 3000, and then again here it will be minus. So, like that allocation gets modified and we get this type of thing 3000, and this is like that. So, now the total transportation cost comes out to be 18938 000, but that means 1 crore 1 crore 89 lakh 38,000. But you know, in some foreign countries they may not understand crore. So, that means it is just we say 18 million means 1.8 crore, like that anyway. So, this is done. Okay. If you have done like this, then again you have to see that there are 9 cells filled, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, what we have to do, that find Uij, Vij for all unoccupied cells, again for all occupied cells. Okay. U1 plus V2 is equal to 1060, U1 is equal to 0. Here quickly I will do like this. If I put U1 is equal to 0 here, that means Patna row has got U1 equal to 0. Then now I cannot find out V1 at this stage because Lucknow cell is empty. but I can find out V2, and because this is V2. So, V2 is equal to, this is basically 1060. Okay. Once I have found V2 is equal to 1060, then I can even find out U2, because this is 1060 and this is, so U2 is equal to basically minus 40. Okay. Now I have done minus 40. Okay. So now we have done like that. So U2 is now known, and now once okay, no, not minus 40, U2 is equal to will be this one. How U2 will be? V2 is known 1060. So U2 plus V2 is 1910. So this is 1060 and this is 90. This one, so 800 and this one 50. Okay, 850. So U2 is equal to 850 rather. Now once you know U2, then only you can find out V1 here, because this Guwahati Lucknow cell is filled. So this is 850 and this is 1020. So 1020 and 850 is equal to 0, and this is 7, and this will be 81, this one. So this is basically 1. Okay. So we say 170. So V1 is, so that way we have found. So V1 is also known, like that we can do that. So let us see that here V1 is equal to 170, U2 is equal to 850. So that way it has been done. It will take some time. Now find Dij for all unoccupied cells, that means opportunity cost, Cij minus Ui plus Vj. So here non-basic variables Dij is equal to Cij minus Ui plus Vj, and I did this one. Now I got minimum negative in cell number 4 2. Okay, that means fourth row and second column. So fourth row, that means fourth row is of Hyderabad and second column means Delhi. Here I have to allocate maximum. So plus something we have to give plus, and suppose I would have given theta, then go move one up. Here you, it is a filled cell, so you can take turning. Here again you can take up to this, you come again you can take turning, and you can do that. That means you can make a closed circuit like this. So suppose this is theta here, this is minus theta, this is again plus theta, this is minus theta. But you see in maximum allocation, if I say minus theta, so this will become 1000 minus theta. 1000 is the was the minimum allocation. Naturally I can put that 1000 theta is equal to 1000. So that's why I have written in Hyderabad Delhi cell 1000, and then this becomes 1000 minus 1000, this becomes 3000 plus 1000, but this also becomes 1000 minus 1000. So simultaneously two cells become empty. So it is better to empty only one, and one you just retain as something like 0 basic variable type of thing. So you just do that. So we have done like this, but you got finally this type of thing. So now the number of now total transportation cost has come down like this, and number of, but now the number of allocated cells is only 8, which is 1 less than 2n minus 1. Okay. So rather I should say which is 1 less than, I need basically 9. Since this solution is degenerate, to resolve degeneracy, one artificial quantity has to be put somewhere. The quantity A is assigned to the unoccupied cell, which will give 0 opportunity cost, that means this much, and therefore here I have written like this. So either you do that, or in the process itself you should not have emptied two things together. In one you would have written A, but otherwise you have to put like that, and then this has become like this type of allocation. Then this apply the same procedure, find Uij and Vij for all occupied cells, and you put the condition Ui plus Vj is equal to Cij. You can start with U1 equal to 0, and then you get these U1 V1 together. Okay. This is what, and then again you find out that opportunity cost Dij, and you get minimum negative in minus 350, that means 26. Okay. Second, so 26 means in the dummy one. So this is 26 that you got like that, 2 Guwahati, and this is 6 is this one. So here I can put plus. Okay, move down, go up to the occupied cell, and then you can take this turning, you can keep moving and you got the occupied cell, again you can move up and then again you take the turning at the occupied cell and then again you come this one. So, closed path has been made. You see in between some filled things I skipped. Suppose I would have come from here to here, I would have taken the turning, but then it would have been difficult to move because there is no other occupied cells. So, we carefully see that suppose we have come up to this spot, then there is a place another occupied cell in which I can take turning. So, anyway this cell is complete and we can say here plus, that means we can say plus theta, then this is minus theta, this is plus theta and this is some theta number, this is plus theta, then this is minus theta. If we do like that, then you see that here 3000 we can do that because minus maximum 3000 is possible. Pay attention to only the negative thing where we have written something minus theta, okay, not to positive thing. Positive thing may be very small, but something plus theta will not make overall negative. So, therefore, here we got 3000 minus 3000. So, we can give so that this becomes 0, this becomes 4000, this becomes 0, like that it has become, okay. So, therefore, now the allocation has come like this, okay. Now, allocated cell is how many? 1, 2, 3, 4, 5, 6, 7, 8 including the 0. Now, which is 1 less, okay, which is 1 less than, okay. So, hence this solution is also degenerate. To resolve degeneracy, one artificial quantity is allocated to Hyderabad and dummy one. So, we have allocated like this, we have done like this and then find Uij, Vj for all unoccupied cells. So, this has come like this and then after that for all unoccupied cells. So, here that one negative. So, now here the most, yeah. So, here Uj and Vj. So, now you do that, I am not completing that, it can be shown, that means if you do that takes time, then you will not have any cell in which Dij becomes negative. So, therefore, you will stop at this that stage and you will say minimum total transportation cost is equal to 1,77 lakh 8 or something. So, you will go by like this and this is how it goes. So, this is the procedure, okay. Let me conclude this, but I will just give a simple problem again. Suppose you have a very simple one, suppose there are 3 plants and 2 market, means I am taking now a simple one. In exam you can get a smaller problem and we keep allocating the amount and we can say that here I have done like this, that here if I allocate plant 3, demand is this one 3700, this is 37 and this is also 37. So, it is balanced one, okay. Now, you can of course allocate some quantities, okay, and then you can do this exercise problem. So, then you can get say suppose I have given that, suppose my allocation is like that, means problem has been given in this way, that I allocated the things like this, okay, 800, 200, 1500 to 1200. You find out whether this allocation is optimal or not. So, for that you just have to find out U1 V1 first. So, you can say U1 plus V1 is equal to 80 and U2 plus V2 is equal to 100, U1 plus V2 is equal to 21, U3 plus V2 is equal to 8. From that you can find out U1 V1 and this one, and then for, so we got this much, and for unoccupied cells you find out that what is Cij minus this one. So, here you got U1 U3 is equal to minus 13 and this much got this one U3 is equal to minus 13 and U1 becomes equal to 80, okay, 80. And similarly here U2 is equal to, I got U2 equal to 20 and this I am getting V2 is equal to 21. So, if you see that Cij minus Ui minus Vj, so this thing will always be now positive, because 102 is a bigger one and this is minus. This is also positive. So that means my solution is optimum. So the question can be given like that, just somebody has given the location, you just have to find out whether it is optimum or not. So this can be done very easily by this one. Okay. Thank you very much for your attention. Okay.